Last video we were looking at high energy collisions, proton-proton collisions, antiprotons, annihilation, and converting energy into mass using pair production. So now we will have a look at the four fundamental forces of nature. This is pretty cool because it's basically what holds everything together. I mean everything, like the whole universe, or universes. We don't actually know whether we're living in a multiverse or not, so that's pretty cool. Alright, so fundamental forces of nature. Okay. And that's Cockcroft and Walton's experiment up on the top right, which they proved Einstein's E equals mc squared equation by observing shooting protons at a lithium target, and it gave off alpha particles. So now we're going to see the four fundamental forces of nature. So we have the strong from strongest to weakest. Strong nuclear force, the strong nuclear. The weak nuclear. Clear. Electromagnetic. Magnetic force. And gravitational force. Right, very good. So that's in descending order now. Let's have a look. So pair production is the conversion of energy into mass. Pair annihilation is the conversion of mass into energy. That's just a key point to keep in mind. So electromagnetic and gravitational forces are easy to observe and have been known for a long time. They have an effect at a great distance and cause many of the forces we see in everyday life. So the electromagnetic force is 100 times weaker than the strong nuclear force. Weak nuclear force is 10 to the minus 13 weaker than electromagnetic. Okay, so I'm going to write that in. So we'll have 1 beside the strong nuclear, we'll have the weak nuclear, 10 to the minus 2 times weaker than the strong nuclear. Then electromagnetic is 10 to the minus 13 weaker than the weak nuclear. And then gravitational force is 10 to the minus 40, the weakest of the fundamental forces. And gravity holds the universe together. So it extends over vast distances through the universe. Universe. Very good. So the ultimate structure of matter, which we will look at in the next video, hadrons and leptons. Okay, so I'll see you in that one.